In this video, we are going to look at kinetic and static friction problems. A 2 kg block is held at rest at the top of an inclined surface which makes an angle of 30 degrees with the horizontal. The block is released. It reaches a speed of 3 meters per second after traveling 2 meters with constant acceleration. Calculate the coefficient of kinetic friction between the inclined surface and the block. Okay, so let's first draw an inclined plane and try to understand what's happening. So let's get an inclined plane. The angle is given as 30 degree. There is a block which is kept at rest at the top of the inclined plane, and the mass of the block is given as 2 kg. So I know that the weight of the block will be 2 times 9.8. So we can write that 2 times 9.8, which will be equal to 19.6 Newton. That's our force of gravity. And then there will be Fn, that is a normal force which will be acting perpendicular to the surface. And because it's sliding down, we can see that it's held at rest at the top of the inclined plane, and when you leave it, it's definitely going to go down. And there's friction on the surface. That's what they are asking us to calculate, coefficient of kinetic friction. So the friction will be acting opposite to the motion. So the friction will be acting upwards like this. Now the first thing, we are going to find the components of the weight, that is gravitational force. We know that perpendicular to the plane it will be 19.6 cosine 30, and along the plane we'll have 19.6 sine 30. Now once we have found the components of the forces, let's just read the question to find out if there is any other information given. They said that it reaches a speed of 3 meters per second after traveling 2 meters. That means Vf is given to us as 3 meters per second. It travels a distance of 2 meters, and they also said that it is released from rest, which is written in the first line. So Vi is equal to 0. We can use this to find the acceleration of the block. So Vf square is equal to Vi square plus 2a delta x using kinematic equations. So Vf is 3 square equal 0 square plus 2 times acceleration multiplied by 2. And this is going to give us the value for acceleration as 9/4, which is equal to 2.25 meter per second square. Now the question is asking us to find coefficient of kinetic friction. So we want to get the equation for force. So we will use Newton's second law, which says that net force F net is equal to ma. And if we apply it along the plane, we can see that there are two forces acting. One is a component of the gravity and one is a friction. And the object itself is accelerating downwards, and that acceleration we have already found. So we can write 19.6 sine 30 minus friction is equal to the mass, which is 2 times 2.25, that's the acceleration. So we can get friction force from here. Friction is equal to 19.6 sine 30 plus, not plus, minus 2 times 2.25. So let's just calculate that. 19.6 times sine 30 minus 2 times 2.25. That will give us 5.3 Newton as the friction force, and we know that friction is equal to mu Fn. That's the formula for friction. And from the diagram we know that Fn is 19.6 cosine 30. So we can just write this down here. Fn will be equal to 19.6 cosine 30. Why? Because the object is not moving up and down perpendicular to the plane. So the net force perpendicular to the plane should be equal to 0. I can use this in this equation. So I know Fr is already 5.3. I know that from here. Mu is what we want to find. Fn is 19.6 cosine 30. And we can use this to find the value for mu. So 5.3 divided by 19.6 times cosine 30. That gives me the answer as 0.31. So that's the value for coefficient of kinetic friction, 0.31, and there are no units for coefficient of kinetic or static friction. This is another problem. Let's look at this. A box is pushed up the incline of an angle of 30 degree with some initial speed. If the coefficient of kinetic friction between the box and the incline is 0.4, calculate the deceleration of the box. So again, we will first try to visualize it. What is the information given to us? We have got an inclined plane which makes an angle of 30 degree. Now here the box is being pushed up. So this is our box and it's being pushed up. And it is asking you calculate the deceleration. So it is pushed up with some initial speed. We don't know what's that initial speed. We'll just write it as VI. So it's just being pushed up and left. So we know that eventually it will come to rest. That means going to decelerate along the plane. So now the first thing we are going to look at the forces. Let's draw the forces on the diagram. As usual, there will be the weight of the object mg acting vertically downwards. We can just remove this VI from here so that we can show the forces. There will be Fn acting perpendicular to the surface, and there will be friction. Because the object is being pushed up, there will be friction which will act downwards. So we'll draw friction downwards as the object is moving upwards. Now we can find the components of the gravity force. So gravity will have two components. Let's show that on the diagram. One will be mg cosine 30, which is perpendicular to the plane, and the other one will be mg sine 30, which is along the plane. Now looking at the diagram, we can see that there are two forces acting on the object. One is friction and one is the component of the gravity, which are going to pull the box down. That's why it is going to decelerate. So let's start with the Newton's second law, which says that acceleration will be F net over the mass. In this case, F net is Fr plus mg sine 30. Because they both are downwards, I can write that as negative. Both of them are acting down. That is opposite to the motion of the object over m. And Fr is mu Fn. And we know that Fn, again, Fn will be equal to mg cosine 30 because the object is in equilibrium perpendicular to the plane. So mu Fn we can write as mg cosine 30. So let's write that, bring that into the equation. So minus mu mg cosine. All the values given to us, a minus mu is given as 0.4 times 9.8 cosine 30 plus 9.8 sine 30, and we can calculate this. So let's do that. 0.4 times 9.8 times cosine 30, and then we have to add 9.8 times sine 30. That gives us the value as 8.29, so negative 8.29 meter per second square. This is another problem where we have a half Atwood machine. If the coefficient of static friction between the horizontal surface and 2 kg is 0.2, that means between 2 kg and this horizontal surface is having some friction, and the static friction is given as 0.2. What minimum value of M2 will cause 2 kg block to start moving? So what minimum value of M2 will start the motion for 2 kg? Obviously, we know that if 2 kg has to move, we have to apply at least the maximum static friction. So maximum static friction has the formula. So friction, I'm talking about static friction, maximum static friction, the formula is mu Fn, we know that. So at least this much amount of force has to be applied on 2 kg so that it can start moving. So if we see the forces which are acting on the system, we can see that M2G is going to act vertically downwards, and as 2 kg will start moving, if it starts moving, it will move towards left, so we'll have friction acting towards right. So that's our static friction. So M2G should be at least equal to Fr to start the motion. If it is less than Fr, then the motion will not start. It will stay at rest. So at least we have to apply the static friction so that it can start moving. So that's what the word minimum is indicating. So now M2G is equal to mu Fn. Why mu Fn? Because Fr, friction force, is mu Fn. Now we know that there will be Fn acting on 2 kg acting vertically upwards, and mg, that is 2 times 9.8, will be acting vertically downwards. So for 2 kg we know Fn will be 2 times 9.8, which is equal to 19.6 Newton. And we can substitute that here. M2G equal 0.2 multiplied by 19.6, and because we want to find what's the minimum value of M2, let's take G on the other side. It will get divided. 0.29 multiplied by 19.6 over G, which is 9.8. So that gives us 0.2 times 19.6 divided by 9.8, which will give us 0.4 kgs. So M2 should be at least 0.4 kg to start the motion for 2 kg mass.